Okay, so welcome everyone to the Land Lab users and developers meeting. Thank you all for joining us. My name is Greg Tucker. I'm the director of CSDMS and one of the Land Lab developers. And this is the second time we've done this. This is just meant to be an informal gathering where folks who are interested in using Land Lab and maybe contributing to it are able to kind of meet with one another, share things you're working on, and that sort of thing. So, um, with me today, we have from the CSDMS integration facility, Lynn McCready, who's going to help keep us organized and on time, Eric Hutton, Mark Piper, and I think I saw Tian Gan somewhere. There's Tian. Um, so here's what I figured we would do. I'll give just a few quick updates on some recent-ish things with LandLab and invite Eric or others to share anything else that they might want to add. Then we'll do a quick round of introductions around the room, and then we'll take some time to do pop-ups. So if any of you are familiar with the Gilbert Club geomorphology meeting, you'll have a sense of what pop-ups are. The idea is just a kind of a 2 minute time in which you can share whatever you feel moved to share, whether it's, giving a briefing on your latest awesome research with LandLab, or it's an idea you have, or an announcement, or whatever it is. So far, I think we've got 4 people signed up to give pop-ups. Um, we probably have time to do as many as, 10 or 12. If anybody else wants to sign up, the link I think is in the chat. So go ahead and do that, and we'll do as many as we can. Um, and then I figured we'd spend the remaining time with small group discussions. So this is a little bit of an experiment, but the way we're going to try and make this work is if you have a thing that you'd like to discuss in a small group, like, for example, maybe it's you're interested in modeling landsliding processes with LandLab, which a bunch of people are interested in now, or you want to discuss how to do a pull request, or you want to, I don't know, talk about working with hex model grids or something like that, whatever the topic may be, go ahead and paste the topic in the chat. And then if you see a topic in the chat that you'd like to join in on a discussion of, go ahead and upvote it by just giving it a little thumbs up. And I figure that way, if we have, I think, 4 breakout rooms set up so we can have as many as 4 different discussion topics, and any topics that get a critical mass, let's say 3 or 4 people or more, we'll have that happen in a breakout room. Sound good? Okay, so let me share my screen. Okay, so just a few updates on goings on with LandLab. Um, let's see. So first thing to say, I think, is whoops, that our list of contributors is growing. We're up to 47 contributors, including many of you on this call. So thank you for doing that. Um, hopefully everybody understands that LandLab is a community package by and for all of us who are interested in using it and contributing to it. So please feel welcome to contribute to it, whether it's something as simple as fixing typos in the documentation, or adding references to the list of papers, which I'll mention something about again in a moment, or adding a new component or capability or whatever it may be. Please feel welcome to contribute. If you are interested in making a contribution to the source or documentation or whatever, but are not sure how to do that, we actually have a webinar about that we recorded last October. You can find it on the CSDMS webinars channel. And basically what it does is walks through an example of how to make a fork of the LandLab source code and documentation, make some changes, run the tests locally, and then submit a pull request to have that merged into the main development version of LandLab, and sort of go through the process of doing a code review. So there's the link if anybody's interested in that. Um, Speaking of publications, our list of publications keeps growing. So we're up over 120 peer-reviewed papers that many of you are authors on. So basically the way we track this has in the past has been every once in a while, I'll go through and just do kind of a Google Scholar search to see who is citing the All About Land Lab papers and whether their paper is an actual using of lab rather than just a kind of by the way reference. So it's an incomplete list, but we try to keep track of it. Um,
Greg, I don't think your
yeah.
slides are advancing.
Oh no? Okay.
You're still on the
Why?
title slide.
Really? Fascinating. Oh yeah, yeah, it's giving me a little message about that. In fact, now that you say that, it says my screen sharing is paused. Why would that be true? Clearly, I am a master of Zoom. Screen sharing is paused. Why? All right. Well, maybe I won't do the
Um,
slideshow
we
mode
can
then.
see your screen. Yeah, it's just not in slideshow mode.
Yeah. I don't know why that's happening. Has the pandemic taught us nothing? Okay, we'll do this the old-fashioned way, even though it's not as big. So this slide shows, hello, slide shows a list of publications. So the publications are stored in a file in the LandLab source base called usedby.md. It's like on the GitHub site, it's right in the main folder. Um, so you can always do a pull request to add references that you want to add to that. Note that that's usually a little bit ahead of the main documentation site, which is in the upper left here. So that if you look just on the documentation and don't see a paper that you'd like to have show up there, first check to see on the LandLab GitHub site whether it's been added. And then if it's not, please either post an issue to say, I'd like to add this reference, or ideally even do a pull request and add it yourself. Okay, a couple of things that are new-ish. I say new-ish because we haven't done a release since last August. So these are things that are kind of in the last year or two. Um, in terms of components, Angel Monsalve added river flow dynamics. And I know, Angel, you've been working on a river temperature dynamics component, which looks really cool. Laurent has concentration trackers that track concentration of something in moving sediment that are designed to work with existing sediment transport components. And Laurent has a cool paper out on that just recently. Annie Thompson has created a shared stream power, a landscape evolution component, and she just updated that to add a new option. Jeff Keck has been adding components furiously, and one of those is the mass wasting runout component. Maybe Jeff will tell us about that in the pop-ups. I know Allison has done some improvements to the network sediment transporter, and there's also been improvements to the uh, radiation component, that is the like solar and long wave radiation. We have, as many of you probably know, now a global grid type. So if you want to do a global problem or a sphere, there's a grid type for that. Sebastian Leonard has made what he calls a framed Voronoi grid, which is basically like you imagine taking a structured grid and then randomly perturbing all the internal nodes by a small amount. So you get some irregularity in the grid setup. That's the framed Voronoi grid. For the tutorial notebooks, Eric has set it up so that we now have a gallery on the documentation pages. So you can basically go straight to sort of browsing through all the different tutorial notebooks and looking at their contents without needing to first download the notebook and run it in a browser. We have the capability to do VTK format output, which is really good if you're going to use like ParaView for visualization, especially if you're using non-raster grids. Eric is always making improvements to our continuous integration system, basically the system that runs all the tests and things on the GitHub repository, and has also been working on various kinds of speed improvements, for example, using OpenMI. So those are some goings on. One thing I wanted to tell you all about that's not in the LandLab repository, but is in a separate one, is a little package that I wrote in order to take advantage of this wonderful visualization tool called PyVista. I don't know if any of you have ever used this, but it's a really cool package that basically is built on VTK, and it gives you kind of ParaView-like capability, but you can run it either in an app that they provide or in a Jupyter notebook. And what it means is you get basically interactive 3D visualization directly in a notebook where you can rotate and zoom in and zoom out and color your surface by different quantities and things like that. So because I didn't want to make PyVista a new dependency of LandLab, I did it as a separate package. It's currently sitting on my own GitHub site, but I'm showing you the link there if you're interested. PyVista is great, and basically what this little package does is it translates a LandLab grid and its fields into the PyVista format, so you can render it. Okay, last or next to last thing is a couple things that are in progress. Sebastian Ledard has written a new flow routing component that is fast and works with different grid types. It's not quite merged yet, but we're getting close. So if anybody's really interested in accessing that and using it, then like bug us and we'll move it up in the priority list. Similarly, I mentioned this last December, but Mark Bain has been leading a project to basically couple LandLab built landscape evolution models with the geodynamics community's flagship mantle convection and tectonics model called Aspect. And as part of that, we're trying to develop a capability for distributed domain parallelism using LandLab components. And Tien and Eric have both been working on that. We've still got a long ways to go. It's kind of early days, but hopefully maybe a year from now, we will have the beginnings of a parallel computing capability. Let's see, in the landscape evolution space, Yuval Shmulevitz and Susanna Moray and I have been working on a new component called the extended gravel bedrock eroder that kind of brings a new approach to fluvial landscape evolution. It's got a capability for either multiple grain size classes or multiple lithology types that will undergo abrasion as they are carried downstream. Hopefully, we'll have that out by the end of the summer. And then finally, we have kind of, as part of that, sort of a little prototype at the moment is a base class for writing LandLab models. So the idea is that if you want to write a model that's end to end, like start to finish, there's a bunch of stuff you need to do, like handling, parameter input and handling output of, the results of the simulation and managing time looping so that you stop every once in a while to write output and so on. So this is basically a base class to handle that, and then you as the modeler can then inherit from that and add all the stuff that's implements your specific model. That's still kind of an experimental thing, but if anybody wants to be a beta tester, you're welcome to just shoot me an email and I'm happy to share it. Okay, last thing, CSDMS annual meeting is coming up. It's going to be in Minneapolis in May from the 19th to 21st. Registration is open, and hopefully many of you can join us there. So let's see. So that's about my updates. Eric, do you have anything you want to share in terms of latest and greatest in LandLab?
No, excuse me. I think you covered it, Greg. Like you said, our release has not been recent. Our latest release is not recent, so I'm getting together a new release, and so hopefully that'll come out shortly. There were a couple issues with OpenMP on some platforms, but we're going to fix that, and hopefully it'll come out in the next week or so.
Okay, cool. So how about let's just do a round of introductions around the room. And since the room has a different shape for each of us, maybe what we'll do is just say your name, where you are, and maybe just kind of a very brief thing about what you're interested in. And then you get to pick somebody else who hasn't gone yet to go next. So let's see. Eric, you're in my upper left, so I'll start with
All
you.
right. All right. Well, Eric Hutton, I'm a LandLab developer at CSDMS and at the University of Colorado. I will pass it over to, how about Jeff? Jeff, do you want to go next?
Yeah, Jeff Keck. I'm a forest hydrologist and geomorphologist in Washington State for the Department of Natural Resources, and I'm interested in landslide sediment production and transport processes. and Matt's Reet. Yeah.
Yeah, hi everyone. I'm Mats. I'm a PhD student at the VU University of Amsterdam,
Oh,
and I work with Benjamin Comforts on post-glacial landscape evolution. Um, I'll go and pick Lester.
Okay. Hi everyone. Well, I'm Lester Olivares. I'm a professor here in Chile, South America. I teach geomorphology, and currently I'm interested into figuring out how soil development actually works, especially in hyper-arid areas, especially, like the Atacama Desert. So yeah, that's pretty much what I do now. Thank you. I guess I'll go to Laurent.
Hi, I'm Laurent. I recently finished my PhD with Nicole Gasparini, using Land Lab the whole time. Now I'm with Natural Resources Canada uh, in Vancouver, BC. Um, I'm interested in everything landscape evolution. So, yeah, I'll go next to Grace.
All right. Hi, I'm Grace Gurian. I'm a postdoc at the GFC in Potsdam, Germany, and I am currently working on the evolution of volcanic landscapes, but I'm also have done previous work looking at sediment cover and layered rocks. Matthias, do you want to go next?
Yes, thanks, Grace. So my name is Mateus. I also actually I'm doing my PhD at VU Amsterdam and 1 year at GFZ, same section as Grace. And I'm working with Benjamin Comforts as my PhD supervisor. So yeah, I'm a big Land Lab fan. I work, most of my interests are same as Lauren said, everything in landscape evolution modeling. But I have a passion for landslides and like wildfires as well. So more into the hill slope processes. And yeah, that's mostly it. I can pass it to Alison.
Thanks. So I'm a professor at Western Washington University, and mostly I work in fluvial systems, and I have been working on the network sediment transporter over the past few years, sort of plunking along, and I'm excited to get to spend April in residence at CSDMS to actually get some things in the main land lab and off my personal branch. I can pass it off to Joe Mason.
I'm at the University of Wisconsin. I've used Land Lab to look at evolution of loess tablelands and the role of closed depressions. That was just published. I'm interested now in the two concentration trackers and possibly using them for organic carbon.
And Joe, you get to point to somebody else.
Sorry. Adam.
Hi, I'm Adam Forte. I'm a professor at Louisiana State University, and I've sort interested in a variety of landscape evolution problems, but at present I've been working a lot on simulating earthquakes and coseismic landslides in Land Lab, and I'll talk about that during my pop-up. So let's see who have we heard from. How about Tian?
Hi, my name is Tian. I'm working at CSDMS team. Right now, I'm mainly focused on the aspect Land Lab project to use Hex and Voronoi model grid to create the parallel workflow. Yeah. I will pass it to Ian.
Hi, I'm a researcher in Flanders, in Belgium, in a research institute. I recently finished my PhD at the Catholic University of Leuven, also in Belgium, and I use LandLab mainly to model overland flow, to assess flood risk mitigation elements in agricultural landscapes. Then Mathilde, maybe?
Hello, I'm Mathilde and I'm in PhD in Grenoble in France, and I work on small catchment. Yeah. So I give let's Grace.
I think Grace has gone already.
Lynn, maybe.
Hi, this is Lynn. I'm the CSDMS program coordinator, and I'll pass it to Jamie.
Jamie, are you there?
Then how about Angelo?
Yeah. Good morning, everybody, or good evening, because I'm connected from the University of Bari in Italy, and here are the 5 p.m. So, yeah, I'm a PhD student during my second year of a PhD course in applied geomorphology. And my PhD project is concerning about the connection between remote sensing techniques and the topographic evolution of badlands. I'm working on the southern Italy badlands, outcropping in southern Italy, and I'm trying to use the terrain Bento package to some way to model the evolution in the brief time, the geological brief time of this wonderful landscape and very peculiar. So I'm trying specifically the basic STVS model to this aim, but thank you, Professor Take, for the last updating, and I integrate and I investigate these last components added to the latest LandLab version. Thank you, and I believe that LandLab is the right tool also to integrate the remote sensing, specifically satellite remote sensing data to the right modeling for the landscape evolution. So I'm trying to do this connection, make the two words talking each other. And so, thank you. So I pass the ball maybe to Benjamin.
Hi, I'm Ben. I'm a PhD student, first year PhD student at EPFL, working with Sarah Bonetti. And currently I'm working on some aspects I'm working on are transport limited landscape evolution and working to relate that to some physical principles related to energy dissipation. And then I think Mark was the last, yeah.
Yeah, thanks, Ben. I'm Mark. I'm a research software engineer at CSDMS. I actually don't use LandLab very much, but I'm very familiar with the code base. And so Eric sends me pull requests and I review them. That's it.
Okay, great. And Jamie, are you there? Okay, awesome. It's great to see everybody. So let's do our pop-ups. I think we still have 4 Angel signed up, but then Angel had to go to proctor a midterm. So we'll start with Ben. Okay, go ahead, Ben. You're on for 2 minutes.
I think you're on mute.
I didn't mean decided for a pop-up. I'm sorry. Am I on the list?
Oh, sorry, it's Ben Cardenas,
Oh, okay. Yeah.
but I don't see Ben Cardenas here, so I guess we lost him. So let's go to Jeff.
Okay, so at the CSDMS annual meeting this year, myself and Erkan Istanbulu, my PhD advisor, will be putting on a clinic for mass wasting runout. Mass wasting runout is a landslide runout model that I mean, there's lots of models. It's somewhat unique in that it tracks the sediment transported by the landslide and it evolves the landscape. And it can be calibrated to replicate realistic runout patterns of erosion and deposition. And at the clinic, we'll go over sort of basic model conceptualization, how to set up the model, and then how to calibrate it. Mass waste to runout has its own calibrator utility that implements a Markov chain Monte Carlo algorithm with a Bayesian objective function. And so it relatively efficiently samples parameter space that'll calibrate the model to a site and saves users the trouble of having, typically you have to calibrate landslide models yourself, or at least that's my experience. And then another output of that algorithm is empirical probability density functions of the parameters that calibrate the model to that site that you can use for probabilistic implementation of mass wasting runout. But so the key objective of this training is going to be to get users to be able to develop their own workflow to set up the model at their own site and then calibrate it. That's sort of our objective. Looking forward to seeing lots of people that I know at the meeting this year there. So, thanks.
Awesome. Thank you, Jeff. Anybody have questions for Jeff?
I guess maybe, yeah, quickly. Uh, could it be used for hazard mapping, kind of like I guess what's the right word? Like probabilistic kind of risk assessment kind of stuff like that?
Yes, the output of the calibrator that gives you the empirical PDFs for the parameters of mass wasting runout, you can then iteratively run the model using those PDFs and develop hazard maps. And I guess you could call the hazard maps probability, but I think there's some debate about like what that probability means because it only reflects maybe like 2 or 3 parameters that you chose to calibrate it to the site, but it does give you like a relative hazard map.
Okay, cool.
Yeah, that part's not user friendly yet, though. I've implemented it at a site. The calibrator utility at this point is becoming user friendly, but that probabilistic implementation, if someone wanted to do that, maybe you could figure it out, but it's still kind of a mess. That part of it is. Yeah.
Okay, thank you.
Yeah.
Okay, great. Let's go on to Adam next.
Hi. I had some slides, but I'm not going to bother trying to do that. So basically I just wanted to sort of like, this was mainly kind of an advertisement of something that will hopefully be coming in the next few months. Myself and my PhD student have been working hard on developing a series of LandLab components that sort of wrap around an elastic dislocation model. And this allows us to basically simulate sort of individual earthquake events over geologic time. So it's sort of a series of components that one allows you to build basically a fault, which you can drive surface deformation with, and then have discrete sort of earthquake sequences that simulate kind of, realistic earthquake distributions. And then recently, while I was at CSDMS during my sabbatical, built sort of a coseismic landslide module that embeds ground motion prediction equations, and sort of talks to the earthquake simulator and allows you to sort of co-evolve landscapes with coseismic landslides and basically makes use of Benjamin Camfort's bedrock landslider as sort of the way it actually does the landslides, but sort of takes care of figuring out where there should be landslides based on individual earthquake events. So everything works right now. We're just kind of like tweaking it and making sure, to find as many bugs as we can, and using it a little bit ourselves before we sort of release it to everyone else, but sort of look for that to be kind of coming down the pipe as an available component or set of components to everyone sort of sometime this year, ideally. Thanks.
Awesome. Thanks, Adam. Any questions for Adam? Okay, let's go to Matthias.
I think Mark has a question in the chat.
Oh, I missed that.
Oh, no, it's okay. I was just running topics for maybe breakouts. Thanks,
Okay.
though.
So is it okay if I share my screen for like 2 slides?
Yeah, you should be able to.
All right. You're looking at my... Can you see my full screen?
Yep.
Okay, nice. Yeah, so I've already introduced myself. So since I started my PhD, I have been working with Benjamin, this full list of collaborators, but mostly Benjamin and Charlie Shoub as well on this fire roller. I can improve the name later. So actually the idea is to simulate the interactions among climate, fires, and sediment dynamics. So we developed this cellular automata model that includes, that includes the fire ignition and spread, fire severity, vegetation recovery after the fires, and coupling with some already available components in land labs such as space and nonlinear diffuser to calculate the post-fires changes in sediment erodibility and diffusivity. It's a relatively simple model, and we only need a few inputs such as this vegetation density field, which is the field that all of the calculations are. The model uses this field for the calculations. So a value for aridity, because we're looking at this gradient in aridity. I'll explain it better in the next slide. A number of potential fires per time step, and of course the topographic elevation field. So some of the first outputs that we have, we are now in the phase of writing the paper out of it, but I think this meeting is a good moment to share the latest updates, and we can have some discussions later. But in general, I mentioned about the aridity. So aridity plays a role in controlling fire activity and vegetation recovery. So in the fire activity, there is this conceptual model between fire frequency and aridity, where you have the peak in fire frequency at these intermediate levels of aridity. So if you look at the plot below that, I'm trying to replicate this sort of behavior in the model for a range of these aridity values. And also the aridity also will control the vegetation recovery rates after the fire. And then we have different vegetation patterns, as you saw in the first slides. And the nice thing is that in LandLab, we can couple that with the erosion component. So if you look at the sediment fluxes out of one catchment in this grid, you can see that the difference in sediment fluxes due to the fire activity. So I think the good thing about this is that now we can dynamic couple fires and these erosional responses in the landscape evolution modeling framework. And it helps us to understand these cumulative effects of fires and also these landscape recovery feedbacks at different time and spatial scales. And feel free to send me an email as well if you get interested in that, if you want to talk a bit more about that. So that was the pop-up. Feel free to ask any questions.
Fantastic. Thanks, Matthias. Questions?
I've got a quick question, Matthias. A couple months ago, someone submitted a wildfire component for LandLab, and I need to review it.
Yes, I saw that.
It
It
oh, you
wasn't me.
saw that? Okay. But okay,
Yeah.
so the first question is that you?
No, it wasn't.
Okay. Could you help me with that? Did you look at it?
Yes, it's a bit different from what I'm doing because if I understand, I didn't look into a lot of details on that. But what I understood is that this model that someone, I forgot the name, tried to put there was like more of a spread, fire spread model, like for one single fire.
Mm-hmm.
And in my case, I'm doing more of a fire regime, so I have like lots of fires in one time step.
Mm-hmm.
And like for the single fire, mine is like a lot simpler. And I focus more in this erosional, like coupling with the erosion. And I think this other pull request doesn't handle erosion, for example.
No, it probably does not handle erosion, but okay. All right, thanks. Well, I still might send you an email for some questions since
Yeah, sure. Feel free.
you're my fire expert now. Thanks, Mateus.
Yeah, thanks.
Oh, that's great. Let's see. So Angel had to go proctor midterms. So Laurent, I think you're the last one.
Hey, yeah, since Joe mentioned it, I just decided I might as well quickly do a pop-up. So I've pulled up a few slides, which I will share. Hold on. I think I might have to do the same as Greg and not share full screen. Um, okay, you seeing my screen? Uh, yeah, so a paper just came out last month on the concentration tracker. It's been in Land Lab, I guess, for probably a year now, but yeah, the paper's out now. And quickly, in case people don't know, it's a model, a component that can connect with the depth-dependent diffuser or the Taylor depth-dependent diffuser for hill slope sediment transport, and with space large-scale eroder for fluvial sediment transport. And essentially, it takes the sediment that was moved by those components and will transport uh, concentrations of user input concentrations alongside that sediment. So it could be beryllium, it could be like a luminescence, all sorts of different things associated with sediment. So an example, just visually here, we've got this kind of mountain range, uh, and I've arbitrarily said that any sediment from there is white and any sediment elsewhere is blue. So this could be like a provenance tracking kind of thing, and you can see that the sediment from the mountains travels through the river channels here. And I'll just do one other quick example. In one dimension, on the right-hand side here, we have a fluvial channel profile and a spike of sediment, imagine taking a bunch of tracer sediment and just dropping it into the channel there. And you can see over time, this spike here, which is the black line, gets eroded away from where it was input and very rapidly gets transported out of this system. A little bit of material is deposited downstream, but not a lot. So you can see this kind of concentration profile grows a little bit and then descends. On the other hand, on the left-hand side, we've got a hill slope with the exact same tracer spike. Ignore the blue and orange lines in the back. You can see that the concentration spike sort of travels down slope in a very different way than the fluvial sediment. So that kind of, I guess in Land Lab, we now have the ability to understand the movement of sediment through time as opposed to just the changes in the depth of sediment or the morphology. So, yeah.
That's great. Thanks, Laurent. Are there questions for Laurent?
Hey, this is Harrison Gray. I have a quick question.
Go ahead.
So I think this component is fantastic. I am really excited about it. So my question is, if you have something like, if you're eroding a unit with, like, say, a detrital zircon spectra, and you want to have something more complicated than just a concentration of zircons, for example, is that possible to do? That's it. Thanks.
Possibly. So I'm no expert on any of the on most uses of this. I you can, if you're creative, you can model a lot of things. So uh, the the model is a mass balance model. So any property that you can uh, model as a mass balance, or sorry, a mass concentration, or a volume concentration, or a number concentration. So, a number concentration, for example, could be the number of zircons per unit of sediment volume. Um, so you can get creative with like I don't know zircons very well, but you can get creative with sort of what kind of concentrations you model. And then I know Adam Forte has worked quite a lot with a very similar sounding problem, so maybe he would know better than me.
Yeah, I mean, so I was just going to say, I mean, so like my PhD student who just finished, Vivian Grom, has been working with Laurent's component to do exactly what you're describing, Harrison, or asking about. And we have a paper that hopefully will be sort of coming out in sort of sometime in the near future. And for that purpose, we effectively had to sort of write something on top of Laurent's kind of code to actually sort of deal with the mixing of age populations where we were tracking like concentration from different units using Laurent's concentration tracker, but then sort of having our own bespoke thing to sort of turn those concentrations of different sort of units within the landscape into different age populations that would get sort of mixed together into sort of, synthetic samples that you could query at different places. So it's possible to do. It just requires a little bit of like extra stuff on top.
Well, that's awesome. I'm really excited to hear more about that work, and thank you, Lauren, for making such a cool component.
A quick question, if there's time. So it sounds like from what Adam just said, you could also have like two pools of soil carbon if you're tracking soil carbon concentration. There would be a way to do that. A faster cycling pool. At a slow cycling pool, you could track the concentrations of both of those. Does that make sense? Maybe do I need to explain more?
I believe so. I'm not a soil carbon person, but you can track uh, different pools, I guess, spatially different or in the same place. You can track kind of different populations of the same thing from the same place. Yeah. Right now, I think it's only capable of tracking one sort of field, um, one grid field at a time. But when I have time, it won't be too hard to make it able to track sort of any number of grid fields at the same time. So if you were to track two separate populations right now, you'd have to run the same simulation twice with the two separate ones. But hopefully at some point I'll be able to do that all in one simulation.
Okay, yeah. And it does seem to work for soil carbon where it's up, the carbon is a single pool is updated each time step because of decomposition and addition of carbon, and then it tracks that concentration through the landscape. So it does seem to be working for that. So
Cool.
Great. Really interested in that.
Thank you.
Yeah, that's awesome. And if I'm understanding right, Laurent, correct me if I'm wrong, but even like now, like before you add the multi-field capability, I think somebody could just instantiate two concentration trackers, right? One for each thing.
That's what we
Basically,
did.
Okay. Yeah. Yeah.
Yes. So we
Great.
had like 3 or 4 running in a single model. You just have to have different instantiations of the same, the component over and over again to have, if you have like 5 units in your landscape and you want to track things from 5 different units, you just have to have one for each unit, basically.
Thanks. That's a great idea.
Yeah, so we're starting to inch toward the top of the hour. So I think I'm going to make the executive decision to forego our small groups, since also I haven't seen anybody suggest or vote on them other than Mark and me. But instead, we've had, I think, 3 folks have joined us since we did our round of introduction. So I'll ask them to do a quick introduction, and then maybe what we'll do is close out the sort of main meeting. But if anybody wants to stick around for the next 10 minutes and chat about concentration tracking or anything else, we'll leave the Zoom call open for you. So let me point to Jocelyn to do a quick intro.
Yeah, hi everyone. Sorry I came in late. I had accidentally double booked myself for a mandatory comprehensive exam meeting for CU Boulder. So, yeah, I am a second year graduate student in Irina Overeem's group, and sort of doing a mix in my own research of numerical modeling, some INSAR remote sensing, and field work, sort of all together. And in terms of the numerical modeling component, I've been playing around a lot with the instructed glacier model, which some of you might have heard about that from Irina or Ethan Pierce. And I'm specifically studying lake terminating glaciers in Southeast Alaska. So because we're thinking about these lake terminating systems, we're kind of in this weird liminal space where we're looking into making some coupled models, and a lot of glacier models don't really have good coupling. A lot of them are very like ice focused, focus on like what is explicitly the ice doing. But in terms of like right flow routing or thinking about a lake or any of the dynamics there, that's something that's a little difficult, but they 100% interact, and they are, if anything, like I'm interested in using LandLab as a way to like try bringing those together, but I know that LandLab doesn't have an ice component. And so I know Ethan has played around a little bit with this, but wait, are we all familiar with IGM? I can explain briefly what that is. Okay, IGM is the instructed glacier model, and it was developed by Guillaume Jouvet out at Lausanne, and it's a ice flow emulator. That's a physics-informed neural network emulator. So it's emulating the Stokes flow, ice flow equations with an emulator. So it has these pre-developed emulators that are sort of ready to go and run. But it's useful because the IGM schema, you don't have to model ice as a finite element model with a mesh that's constantly changing, or you can use a more rigid grid, which is obviously what LandLab is a little bit better for. But it of course uses TensorFlow, which is like another dependency that LandLab might need. But it's one of those things that like I'm currently working outside of LandLab to do this coupled model with the lake. But one thing that my group is interested in thinking about long term is that if we want to do a long term landscape evolution model that includes glacier termini that are moving into a zone that might have a lake, moving out of a zone that could develop a lake, there's kind of this dynamic component that would need to be there in this linking. And right now, yeah, it's definitely a problem that like is on the back burner for me. So I'm sort of joining in and wanting to be part of these discussions, obviously, but it's not something that I'm actively developing, but it's something that I'd love to think about.
Yeah, that's great. Thanks, Jocelyn. I mean, we definitely need and should be able to have glacier components in the system. So hopefully we'll have that soon. Let's go to Dewan, if you're there. If you would want to
Yeah,
just say a quick introduction to who
sure.
you are and where you are.
Good morning, everyone. I am Diwan Haq. I am from Louisiana State University. I am a PhD candidate here. Uh, I am a LandLab user, and I use LandLab for currently. I am using LandLab for couple landslide and flash flood modeling, and I'm currently investigating how to integrate especially variable parameters. For example, especially variable soil depth or like cohesion, friction, those kind of things uh, in a model. And I'm glad to see so many familiar face once again.
Great, thank you. And I think last is Harrison.
Hi, everyone. I'm Harrison Gray. I'm a research geologist with the U.S. Geological Survey. I sort of co-direct the luminescence dating laboratory, and that's kind of the main thing that pays my bills. In addition to that, I do some work with LandLab. I'm a LandLab user. Um, right now, I'm pretty interested in using LandLab and the concentration tracker to explain sort of changes in class provenance for parts of the lower Colorado River corridor. And I kind of have a feeling that it could be used to test in member models for the incision of the Grand Canyon. So yeah, I think it's a really exciting, big LandLab fan. So, and sorry I'm late. I had another project meeting I had to go to, but thanks for organizing and letting me attend.
That's great. Thanks, Harrison. Well, so I think that covers pretty much what we wanted to cover. I'm hearing a lot of common themes. It sounds like there's a kind of a cluster of folks who are interested in either badlands or agricultural landscapes, or like in Joe's case, lush landscapes that are in some ways soft or eroding fast. And so that's cool. I think there's also a overlapping set of interest around overland flow hydrodynamics and how that works. Definitely a lot of interest in tracking things like carbon and zircons and all sorts of things. So maybe these are things we can pick up next time we meet. As I said, so we can close out the formal meeting here, but we'll leave the Zoom up for a few minutes if anybody has any other questions to raise, discussion points, you want to talk to one another, whatever the case may be. But thank you all for joining us, and look forward to seeing you next time.
Bye.
Greg, I had a question about the parallelization you mentioned. Um, is just big picture, is that something that would require any changes to components? Like, or is that sort of all kind of under the hood making the grid function faster, or like
Yeah. Really good question. Yeah, I think the answer is it depends. I mean, it's I don't know, Tian, you may be in a better position than me to answer this, but I'll take a shot and then let you add whatever you would like to add. But so for components that are basically like traditional numerical solutions to discretized problems, I think what's going to happen is like there'll be machinery that like Tian has been working on and Eric has been working on that will provide a way to decompose the domain and exchange data across the boundaries. I mean, that's the key thing. And so the components themselves shouldn't have to change with that. They will just basically, you'll have like one patch, one domain that only knows about itself, but then there's some external code that is smart enough to say, okay, let's exchange information across the boundaries and update the boundaries of this little patch. And the component only knows about its own patch, and it sort of knows that its boundary values have been updated, that kind of thing. Some components, though, and especially like the fluvial thing, that's a whole different problem because that's like a non-local thing where, the water starts at the head and it goes any which way across the whole domain. And so Wolfgang Bangerth has developed a matrix-based prototype that will do that fast. And hopefully that can be spun into a LandLab component at some point. And then Eric has been working on a different approach where you kind of like send water from one patch to the next patch and you keep iterating until you've solved the whole system. So for those Non-local problems is a little more complicated, and that does, I think, require components to be changed.
Okay.
Tien, anything you want to add to that? Did I more or less get that right?
I think you're correct. You covered what it is right now. Yeah.
Laurent, I actually had a question for you, also with the concentration tracker. Um, uh, just sort of some issues, or not issues, but like some things that Vivian and I have been kind of running into with or thinking about is like basically, have you experimented much with like the diffusion tracker for diffusion and the tracker for like space talking to each other? Or like I mean, because like the examples you were just showing were sort of like, one is
Separate.
fluvial, one is
Yeah, yeah,
diffusion,
yeah.
or one is hill slope. And so just sort of trying to like simulate a landscape with both, we kind of realized after the fact that we had sort of been ignoring hill slopes and only using the one for space. And then it was like, oh, maybe we need to actually go back and redo everything because we didn't deal with hill slopes.
Yeah,
So
I have used both. I have not. I'm trying to remember. This was a little while ago. Yeah, I've used both. I've made sure that they can function together.
okay.
And it does seem to work. I haven't done any like in-depth kind of testing, but it all like functions as a system. If you like really dive into how, yeah, I mean they should work. Like essentially anything weird that comes up would not should not be because of the concentration trackers. It should be because of the two formulations of how sediment moves. If you get little weird pockets of like concentration spiking or something, that would be probably just um yeah, kind of bigger picture how we're modeling the two processes. Yeah.
Cool. Well, we might be reaching out to you at some point with
Okay.
some finer
Cool.
scale questions if we need to. But yeah, thanks.
And likewise, in the other direction, I had been wanting to do an earthquake and co-seismic landsliding stuff in Land Lab, so I'll reach out to you as well.
Yeah, they'll be happy to chat about it.
That's why we're here. All right. Well, we've hit the top of the hour. Thank you all for your patience. See you next time.